So we're going to do a little recording then to kind of walk people through the assignment if you missed it or if there was something that you weren't sure you quite caught on to and wanted to get clarified. So uh, as we do this, again, if you haven't already, I want you to be sure to open up your assignment for today in the Schoology folder. Again, it's going to be a Google document that you will need to that you're going to need to copy, and then you're going to be able to edit your own copy of it, and then you're going to share that with me. But as you look here, this is the document, what it's going to look like, at least the top part of it. It's going to have 6 different columns that we're going to fill in, and about 10 different rows that we're going to fill in as we try and do some different formulas for some different reactions that might happen. You'll see the first row is really done for you. For the metal, in the first one, we're going to be Na, we're going to be sodium. And for this charge, we see that the charge, if we look on that periodic table, is going to be a 1+. The non-metal is going to be S, or sulfur in this case, and its charge is going to be a 2- charge. If I were to do a formula of combining those two and making an ionic compound, if I crisscross those charges, my formula then gets to be Na with a subscript 2, and then S. S1, but of course we don't write the ones in the formula. And then last but not least, the name of the compound, the last column, is going to be the full name of the metal. The root of the non-metal, in this case sulfur, becomes sulf, and then I add that IDE ending. And so what we're going to do is I'm going to go through a number of these. I'm not going to go through all of them, but hopefully it's going to help you be good and prepared. And you're going to be able to answer the ones that we don't do together. You'll be able to handle that a lot easier. So as I go through this is not going to look exactly like yours, as yours is going to, as I said, be kind of in that table form. Mine is going to be a little bit smaller than that, okay, or a little less organized, but I'm using this program that I can write with, so that's going to be the key here. So I'm going to change over here to my pen. And your first row that we're going to be doing, okay, gives you the K and gives you the N, gives you the metal and the non-metal. Now, for those of you who are getting handy with learning the chemical symbols, hopefully we're going to be able to recognize these real quickly. But the K is going to stand for potassium. Okay, if you find it on your periodic table, it's going to be number 19 on your periodic table. It's in group number 1, or the alkali metals, and all the elements in group number 1 have a 1+ charge. All right, so I'll plug in 1+ there for the charge. N, if I find that on my periodic table, number 7, it's going to be nitrogen. It's in group 15. It's the first element in that group. And all those elements, they've got 5 valence electrons. They want to add 3 more, so they're going to have a 3- charge. All right. Well, knowing this, then, I've got my charges. I see that the charges don't add up to 0. I got a 1+ and a 3-. So now I'm going to go ahead and do my crisscross method. All right. I'm going to take my 3 from the nitrogen. I'm going to write that as my subscript for my K, or for my potassium. I'm going to take the 1 from my potassium charge, write that as a subscript here for nitrogen. Now, of course, when I actually write out the formula, we're not going to write the 1, are we? Okay. It'll just be K with a subscript 3 and then N. All right. The name of the compound, okay. The name of the compound, again, the full first name of the metal, which in this case is potassium. So I'll write in potassium here. The anion, or the negative non-metal, what we need to do, again, is take the root, which is again going to be kind of that first syllable plus any consonants that happen to be alongside that. In this case, we're going to include that R, so niter, if you will, and then I'm going to add that IDE ending, nitride. So the name of this formula, K3N, is going to be potassium nitride. The next problem here is going to give you the formula, and your job then is to fill in the other boxes accordingly. I got Mg and F, formulas MgF2. Well, the metal then, metal always comes first, so I can go ahead and I can, well, I'm going to go ahead and keep it the same color because that's the color coding that yours will have on it. So Mg is going to be my metal. The second element is always going to be my nonmetal. So I'll write my symbol for that is F. Okay. Oh, once again, I guess I'm going to keep it color coded. I'll go ahead and do that. Rewrite that. Now, if I look these up on the periodic table, I can absolutely do that. Mg is magnesium. It's number 12 on my periodic table. F is fluorine, number 9. And then I can look at those charges. I also could find the charges kind of indirectly here by just looking at my formula. Okay. I know it's MgF2. Well, that 2, if I kind of do the reverse crisscross, that 2 came from the fact that magnesium must have been a 2 plus. All right, so the charge of magnesium is going to be 2 plus. Now you see there's no subscript down here after the Mg. So that's going to be kind of the assumed number 1. And so again, that must have come from the fact that fluorine is a 1 minus charge. All right, because we don't write the 1s. As far as the name goes, again, same concept. Full name of the metal. Mg is magnesium. F is going to be fluorine, but of course I'm not going to write fluorine. I'm going to take that first part and then change the ending from fluorine to fluoride once I made that ionic bond. If I go to the next one there, you see it gives me Ca and O. And now again, hopefully we're becoming pretty handy with these names. I'm getting used to Ca. Ca is calcium. And I find calcium, number 20 on my periodic table, right? It's actually right below magnesium in group number 2. So it also has a 2 plus charge. Oxygen, number 8 on my periodic table, first element in that group. In group 16, has a 2 minus charge. Now I wanted to do this one because, we've kind of been doing the crisscross method. And if I were quick to do the crisscross method on this one, I might think of that my formula is Ca2O2. But that would not be correct. Remember, the first thing we want to check is to see if the charges cancel each other out. In this case, they do. The sum of the charges is already going to be 0. And so what I'm going to do is I'm just going to write my symbols down, Ca and O, CaO. That's will be the formula for those 2 elements coming together. All right. And we want it to be a 1-to-1 ratio instead of a 2-to-2 ratio, if you will. The name, I can go ahead and do that quickly. Ca is calcium. O again is oxygen. First syllable is ox, and then I add my IDE ending, calcium oxide. All right, so next then, next I'm going to go ahead and I'm going to skip down a little bit here. I'm not going to do the very next problem. I'm going to let you guys do that one on your own. All right, but we are going to, and I know this is probably I'm going to have to redo it again. Yeah. For whatever reason, this program shuts off once every time I go to full screen. But if I go here to slide down to where it gives you copper 2 chloride, okay. Copper 2 chloride, it gives me that the symbols for copper is Cu and the nonmetal is Cl. What we need to recognize in this problem is we've got one of those Roman numerals. Okay, copper falls into the transition elements. And so some of those, of course, we said have what we call multiple oxidation states, or they can have multiple charges. And so we will use this, Roman numeral to indicate the charge. That Roman numeral tells you, in this case, that copper is a 2+. That's what it is indicating. That's what the Roman numeral says. So for my charge for copper, I can go ahead and write in a 2+. Chlorine, number 17 on the periodic table, another halogen, got a 1- charge. So when I do my formula now, I can go ahead and crisscross again if I want. I bring a 1 down, bring a 2 down. And so my formula then is simply going to be CuCl2. Notice the Roman numeral doesn't, we don't try to squeeze a Roman numeral in there. A lot of people like to try to do that. The fact that it's copper 2 is going to be indicated by the subscript after the chlorine. All right, last one I'm going to do for you, and the rest I'm going to leave on your own, is the one that starts with NH4, okay, under the metal row, or the polyatomic ion row. And that's exactly what I have here. Notice I've got more than one symbol there, don't I? Oh, I've got a polyatomic ion there, NH4. And if I look on my table from our notes, I can find its charge. Actually, the question actually gives it to me as a 1+. But NH4, okay, happens to be a polyatomic ion known as ammonium. All right. And if I keep sliding across, I see sulfur. I want to find its charge. Sulfur is actually right below oxygen on the periodic table in group 16. So just like oxygen, it is a 2- charge. If I crisscross my numbers, my charges, subscript 1 for the S, which of course we're not going to write, and I bring the 2 down here, and you say, whoa, Mr. Call, that doesn't look right. NH42 is what it looks like. Well, of course, we're missing one key component, and that is that when I have a polyatomic ion and I've got to have more than one of them, I need to drop in some parentheses around it, okay? Because I want it to be clear that I have 2 of these ammonium ions, all right? And so when I write out my formula, I'm going to have a parentheses with NH4 inside, and then a subscript 2 on the outside. And then, of course, I'll just write my S for my sulfur, but I don't write my 1. When I name it, I don't change the name of the polyatomic ion at all. I've got ammonium again, and now I've got S, which is sulfur, root of which is going to be sulf, and then once again, I'm going to add that IDE ending. Hope that helps, and hope this sets the table for you being able to finish the rest of those questions. Again, you are able to use the notes. The last 2 questions will include polyatomic ions. I think you'll see nitrate show up, which is going to be a 1- charge, and I think the last one has sulfate in it, which is SO4 and a 2- charge. Again, no one's going to make you memorize the polyatomic ions, but we do need to know how to work them, and hopefully, like I said, be able to recognize when they are there. All right, good luck, and thanks for watching.